Hello and welcome to this first presentation on the basics of using MakerPlot-J. We're going to take a look at some of the basic features with it and see it accepting code from the microcontroller and plotting with it and doing various tasks. So let's go ahead and open up MakerPlot-J. Now when it first opens, you may for a moment get a version update notification if there's been a new version posted. We're going to cancel out of that for now. I'm running a newer version that's posted right now. So what we see here is what's called the main interface. Okay. The main interface consists of a lot of different controls for plotting and for gauges and for meters and indicators and things like that, buttons. There may be sometimes where we have other interfaces that open from the main, and those will be called child interfaces. And these are the various interfaces that are installed with MakerPlot-J, and we can see down below here, scroll up and down with these, and usually starts a little bit lower down, but scroll up on those and read about that interface and get some idea what it's about. Okay, and this is a MakerPlot-J interface itself that was developed just to select another interface to open. So we'll go ahead and open up this first one, plot in 4 meters, and look at some various tasks with it. Of course, an important point is to be able to accept data from microcontroller. And we do have some sample code that installs with it. We're going to go to the Open Microcode folder. Okay, and from there, right now we just have Arduino code posted. But there's one here called Sine Cosine Digital, which works with majority of the plots or the interfaces. They're selectable. And so we'll pop that one open and just take a look at it and see what MakerPlot requires for the data. Okay, so we have the code here, and it doesn't do much important. We just count through a couple of variables, X and Y, do some sine functions and some various math just to get something interesting to plot on the screen. And the important point here is a serial print, and that we're going to print an analog value, comma, an analog value, comma, an analog value, comma, analog value, and this last one ends with a print line. So we get that line feed at the end. Okay, that's important MakerPlot to see the end of that string that's coming in. So let's go ahead and upload it to our Arduino or COM7. And let's go ahead and upload it once. Filing sketch. Okay, we're going to pop open the serial monitor just to take a look at that data once. Also down below, we do some digital data. So we can plot some digital data later on, and digital data begins with a percent sign followed by the value in binary. So it's percent 1001 and so on and so forth. All right, so let's go ahead and look at that serial monitor and see this data coming in. It allows me to. I'm on the wrong baud setting, of course. Let's go back to 9600. There we go. That's much better. Okay, so let's go ahead and pause this once. Take a look at these strings of data. Now, way up above, we missed it. Let's go ahead and let's resume here for a second. Oops. And let's reset the controller. Set button. Okay, and it started off just saying starting data. And that's known as a message. It doesn't fit the categories of analog data, which is value, comma, value, comma, value, or digital data, which is percent sign 1 or 10 and 11. etc. So we just send a message string. Then analog data, digital data. We can see again for the analog data, it's just comma separated values. For digital data, it's a % and 1, 101. Okay, so then now that's going in 600 baud. We're ready to bring that data into the microcontroller. So make sure we close down the serial monitor here so we free up that COM port. This, expand that out. Second stabilize, okay. And we can see down here on the serial control, okay, it's selected to our Arduino Uno COM7. And if there's other connected devices, we can see the various COM ports and select the one we want. We're at 9600 baud. If we plug it in late, we can refresh and update what we see there for the serial controls. DTR enabled, we can use that to reset the controller on connect, so we get that first bit of information coming out of it. And it's important in the code too to have a little pause after you start the code up, give it a pause or so, and just send a blank line feed and some data so that first information isn't garbled. Use COM string. There's a communication string associated with serial control, and right now what it does is it clears the plot out. And so when it does connect, it will automatically clear that plot and reset it back to time 0. Okay, so let's go ahead and connect. Okay, first we get a message box popping up because we sent a message. So it says starting data. Okay, that was just the message string that was sent. Plus it was shown down here in the message text box that's on the screen. So we can send messages and have them appear either in that box or down here for this example application. So we'll close this down. Okay. And we start bringing in that analog data and we're plotting it. Okay, we can see the received light going. We're not transmitting anything out in this example. And so we're just sending the information across. Okay, so it's pretty easy to get analog data being plotted, just COM separate values being sent to this. I'll show something else right now. We're going to open up the debug CLI and just show an example of sending data that way. So I'm going to hit F4 to open up the debug window. And we can use this to send whatever we need to instead of from the controller. We can just type it in. So let's do one for 200, 200, 200, 200 for 4 channels of data. And we can see those are all plotted together up in that big bump up there. So we can use this box, the debug CLI, to do a lot of things. One is just to send some sample data so we can see how the controls and such interact with it. Okay, also on the screen, we've got a few things going on here. We've got our meters updating, and these are reading the various channels. We'll take a look at one of those once. We can set the min and max on these, set an alarm min and max, whether the alarm's on or not, or sound alarm. So we can alarm and not sound the alarm if we want to. Okay. With data source, when analog data comes in, it comes in as what's called the values of AN0 to AN1. But in this case, I'm taking the data from the plot itself. So I'm taking the plot object channel 0 and using that for the meter. If we look at this one, of course, it's going to be plot channel 1, and so on and so forth. So we can tell what channel of the plot we want to accept. And that first string of that first value of data coming in is channel 0, then next comma channel 2 or channel 1, comma channel 2, comma channel 3, and so on and so forth. On this interface, we also set meters to plot scales, so we can just automatically scale these meters to the plot scales of 232 and minus 154, so automatically scales for that range. Okay. Now for alarms, we want the alarm. We can double click this meter to turn the alarms on. It shows up red when someone out of it. It Oops, we'll get back into the clear here. So there we go. We'll turn green when we're not alarming. High. And there are events that occur that we can write code, MakerPlot script, when alarm happens for something to go on besides the built-in buzzing sound of the meters. So that's all code we can write for it. We'll talk about this one. Okay, so we have the various meters going. Okay, and corresponding to our values. And of course, we can set the min and max on this. Set minimum to -100. Oops, I was trying to set the alarm. Set alarm minimum to -100. And let's set alarm max to we'll do 200. This has got a little bit more room to work there without taking the alarm set points. And of course, it shows you the current value down here. Okay, also on the screen, we're seeing the minimum for channel 0 is listed down here, plus the maximum value it reached. And that was the 200 we typed in earlier. It's set that as being the maximum. Or we can select a different channel to monitor, such as channel 1. From here, if I want to, I could turn off channel 1, okay, and not show channel 1, or show it. Okay. Or I can clear the min-max average here, which will clear the values that's using for auto scaling right now. Still adjusting a little bit. Okay. Over here is data logging. Okay, we can enable logging, open the log up. So let's go ahead and we'll enable logging on this. I collect a little bit of data. It shows that it'll change the time every time it collects a sample. And we don't have to turn it off first, but we can open the log up and see that data that we've collected. Now with the log control, we can double click it, and here's a lot of different things we can do with it. Okay, what file we're going to set to, what log string do we want to, if we want to use specialized log string, we put that in, log all analog data, log all digital data, log message data, whether to use a log string or not. So we can define exactly what it's going to be using and storing as it goes. Again, with the log string, again, we can call up the plot time in seconds for that first field, A and 0. Again, we could use here instead, we could use plot.channel0 and plot.channel1 and plot.channel2, for example. A and 0, A and 1, A and 2 is the raw data coming in from the controller as it first comes into MakerPlot. It's called A and analog N0, analog N1, analog N2, etc. We can set trigger conditions. If some value exceeds something, we can have a trigger to only log of that time. We can also save snapshots if we want to, and be able to record those snapshots of the plot or of the interface, and be able to store those. So there's a lot of things to do in the data logging control. That reference files are pretty extensive on it. Close that down for now. Also down here is a snapshot where we can give the snapshot a certain name and then say snapshot. Okay. And then open that snapshot up so we can instantly record that and see what that looks like. And over here is that text box again, and we can clear the text in it if we want to. Okay, and this is all code that's written behind the buttons that we'll talk about later on, but most of it's pretty simple instructions to do various things with the various objects and controls on the screen, on the interface. So let's look at this plot going. Okay, a lot of things are going on here with it. Let's do a once around on these various controls. Okay, these boxes here, okay, can be used to set the axis values. So if we want to see 200, right now we're auto scaling. So if we put 200 here, right now I'm on auto scale, so auto scales for me. I'm going to turn that off. So I get 200 now. Or perhaps if I want to, go down to minus 200. Right, so we can, and same for the x-axis. And again, right now we're auto scrolling. And so if I try to set those, it's going to start shifting on me and changing the span somewhat. Okay. But we can shift that plot up, okay, to adjust it, or shift that plot down. We can double span on it, or we can half the span on it. Similarly here, I can shift that back, or shift it forwards, or double the span, or half the span, or auto span it. So we see everything that's come in so far. It can be a little bit overwhelming at times of how much data we've got. Here's a big spike over there, 200. Okay, so let's half that a few times. Okay, get some data going, turn shifting back on. Okay. My pause isn't showing up here for some reason, something to debug. But there's a pause button here to pause plotting and then resume it again. This will turn plotting on or off. When you turn back on, it resets the plot. Okay, so be aware of that. This returns the axis to the last set values. For example, if we were, if we totally lose this plot somehow, we can't find our traces, we can reset X and Y coordinates to get back to what we set them to. And this is to reset the plot, reset it back to time 0 again, start plotting over. Okay, this is automatically shift when it reaches the maximum on the x-axis. Let's bring this down so it's a bit faster. Okay, this is reset when it reaches the max. So when to reset, as soon as it hits the max, we can do that. And again, there's event code that we can write. So right when it resets, we can take a snapshot of it or something and start storing all the snapshots of it resetting. It's a little bit of code to write if you get in the development side of the house. This is down here then. This is halt when it reaches a max. So it reaches the max, it's going to halt that. And it turns the plotting off. We turn back on, and it does it again until it reaches the end, so we can get one sweep of it across the screen. So a single sweep type feature there. Down here, we can take a snapshot of the plot alone, and that saves it to the snapshots directory. Or we can save that data. We can save the data that makes up that plot, then reopen it with load data. Okay, so we can go back to a previously saved plot and analyze it a little bit. Go a snapshot, take a snapshot, folders, and here's our snapshots folder. Okay, so there's our plot right there, analog plot. It names it after the title of the plot and appends the date and time, so it's unique. Okay, some other features of the plot. Let's go back to plotting here a little bit. Well, it's paused right now, it's fine. Now I'm just gonna click my left mouse button and drag it. I can drag those traces around the screen. So again, I can reposition it. If I use my scroll button on the mouse, I can zoom into a certain location or zoom back out again to that location, such as the scroll mouse by itself. If I right click, what I can do is up here right now as I move this mouse, every second or so, a couple seconds, it's updating the X and Y coordinates of the pointer on the screen. Okay, so we can go to a point and see what that is. When it's plotting, it'll update very quickly. Let's turn plotting back on here. Right. So as I move this around, it updates a lot more frequently, so I can measure things and see what value that is, or we can click on the screen and get that coordinate as well if it's paused. So let's go ahead and pause it for a second there. And again, we click that screen, we can click that point, we can get that value up there and see what it is as far as the X and Y coordinates are of it. This dx and dy, if I right click, I'm going to change my axis here once. I'm in hours, minutes, seconds. Let's go ahead and change this. I'm going to right click on the plot, put a plot style, and say, don't show me hours, minutes, seconds. So we just get seconds down here. It'll make a little more sense when we do this. But if I right click and drag, you get a red line there. That will tell me the distance between those on the X scale, the X axis, or on the Y axis. Okay, be able to get those distances. And also it will calculate the slope of that line. So it's got a slope of minus 187.3, steeper, and that's dy over dx up here. I'm looking at dy over dx. Okay, whereas the distance is dx, x distance, y distance, and then the slope. Again, going across there, I can see the slope dy over dx. And the slope gets very high. Sometimes I'll get infinite up there as I hit that sweet spot of 0 on the x-axis. Also shows the frequency between 2 points. If we look at what's the frequency, oops, draw a line between those 2 points, and between those 2 points is a frequency of 0.38 hertz. Okay, so just some basic measurements with that plot that might be important to folks. Those were actually requests to be put in by a researcher. And so I was happy to do that and make it a little bit better. Okay, let's go ahead and unpause there. I know that's not showing. I didn't update the media files in this one yet. I should download that update. So I've had that icon for that. Okay, we also have scroll bar down here, so we can scroll this and go back through the span of that plot. Okay. Using the mouse roller, okay, we can do very fine positioning of that. We're holding down the shift key, we can shift by entire pages of that plot and zip through it and see all the way across those as we jump by page by page by page. Couple other things on here. One is this bar up here. Let's look at all our bars. We got a bunch of bars around here. And there's only a certain number of data points we can store in memory to keep redrawing that plot. And you just can't store forever, so there's a limit on how many data points there are. By default, I believe it's at 10,000. So it's going to start at 10,000 points for all these various traces. So it can redraw from those. Now, what happens when this gets full, the oldest data will start erasing, start disappearing as it dumps out of memory. So that's an important consideration when you look at how much data you want to store. Just that, we can go to Settings. And down here is maximum data points per channel. Right now it's set to 10,000. We could increase that. Just make sure you hit Enter after you type a value in. We can also go ahead and change our grid color, for example. These are supposed to update to the current color. Sometimes it's not doing it for me. There they did. Okay, so we want to change the grid color. We can go in there and make it green instead, for example, for our grid. Or the axis color, the back color of the screen. You can change the title of the plot. Data. Okay, we see it change up here, my data. We can set the axes down here as well if we wanted to. Number of grid lines, major and minor. No change, skip storing. If I have a straight line here, just to conserve those data points, I may not want to store every point just because it's a straight line. So if I get 20 consecutive readings that don't change, then don't save those as data points. There are some functions when we read, if we perform math on the collection of the data, like reading all those CSV values have been stored for a trace. It might be important to store every one, where we'd set that to 0. If we wanted to find like a deviation of that entire line, which is very possible. But in general, it just depends on your needs and such. Showed channel legend, turn the legend on or off. They get rid of the text boxes there as well. That's the nice thing about this video is I find everything wrong. Or just turn the values off so then update. And we'll look at that legend here in a moment as well. I keep forgetting to. Under channels, we can select the colors for the various channels, and we can turn them on or off from here. So we can turn off channel 1 and have that disappear. For auto scrolling, it would adjust to the new min max based upon only what's being shown. We can change the name of that channel. Okay. Temperature. Okay, so we can update that. I want to keep it a little bit short there, but it updates the name of that channel, so we can adjust that. For formula, by default, if it takes A in 0, plots it for this. Takes A in 1, plots it for this. Takes A in 2, plots it for this. But we can put a formula in here, such as take A in 0 and multiply it by 2. I'll move that off there so you can see that. And let's turn that channel back on so we can see that now. And so now it's at that point, then it's been multiplied by 2, so it's twice as high as it was before. We'll go back to nothing here so you can see the difference. Okay, so we turned off multiplication of that channel, so it's back to normal. And there's a lot of sophisticated math functions we can use in MakerPlot. It's all referenced in the help files. We can change the analog width of the channels, make it fatter if we want to. Get this right. So 3, make it a little bit thicker. And a little description down here of some of these things. Okay, so let's take a look at this. Again, we're showing our various channels, showing the values. As each one comes in, question marks just mean it received no data for that channel. And again, up here, very quickly, we can turn back on auto scrolling. Clear my min max real quick here. You can see it settle into its min and maxes. Give it a second here, waiting for channel 0 to come back down again. That's the biggest one. Okay, so we can turn that channel off, and we can see it shift now to show the min and max of those. Okay, so each interface, the plots will always work the same. What's on the interface is unique for each one, and some of the controls and functions on them. And just right-clicking again for the pop-up. There's a lot of things down here. We can turn those icons off. We don't like the screen clutter, or turn off the axes if we don't need them. Make the screen a little bit cleaner. We can reset the min-max average here. If we get into drawings, we can clear drawings and clear constant drawings, where we can use drawing instructions such as draw a line or draw a circle and put things directly in the plot itself. To be part of the plot, we can reset the plot from here as well. Save data, again, save that data set and then reopen it again. Okay, so that's about it for the plot and such, all the major features on it. Let's go ahead and look at some menus. New interface, I can totally delete this interface and start building a new one from scratch and putting a serial control and plots on it and make it exactly the way I want to. Cover that, this one. Open selection interface will bring us back to the plot select screen. Interface to load on start. When we start up the software, which interface do we want? Do we want the selection screen? Okay, so we can define use selection interface, or we can choose the that's the selection screen here, index, or we can select an interface to use, or use current interface. Okay, this interface, that's next one. That's what I want to come up next time I open it. So I can say use current interface. So it pops up and ready. And whether we want to load on start or not, that's just a blank screen. Our recent files have opened. Now we can open an interface, an MPJI file, MakerPlot-J interface file, or we can save an interface. Now, if you have a non-developer's license, okay, where by development you make your own interface, you put the meters on there and whatnot. If you bought a license for non-developer, then these will be grayed out. You won't be able to save interfaces. You can create an interface all you want, you just can't save it. Or we can save interface settings and reload them. Let's go ahead once. We've got these meters and scale set to various things. I'm going to save this interface once. So let's save it as, let's call it test. Okay, so let's go back and let's reopen the selection interface. Let's go back into that same interface. And now let's reload settings. I'm going to load in the interface settings. And I called it test. Open that one up. Load interface settings. Test. Open. Okay, I was waiting for these meters to update, but they didn't on me. I tested this right before I did this, and it worked fine. So, okay, but it should reset the meter to the parameters that we had. So I'll take that code again. And anything else that we changed, it should update, and any changes that we made to the interface itself, it should update those changes. Now, as far as controls go, but it'll save all the properties of all the various controls and such. So when we reload the settings, we get back to what we wanted or how we had it last. So I'll check that out. Okay, and again, we're just ready to plot and keep on going here if you want to. There we go. Okay, and that's our first video. I hope it's beneficial to you. And we'll go through and look at all the various interfaces and just point out some things in our next video. Thank you very much. Happy plotting.